find an equation of the line passing through the point -4, 3, but we want it to be, the line is going to be parallel to this line. Okay, so let's graph this line. Okay, find out an intercept, find out the value of x when y is 0. Okay, well, if y is 0, what's 3 times 0? If y is 0, if y is this, then you're going to get 3 times 0, which is 0. 2x plus 0 is 2x. This goes away. If y is 0, then this goes away. Okay, that makes x equal to 3, doesn't it? 6 divided by 2 is 3. So come over here, 1, 2, 3, and graph that point. Cool? Now get your line and let's get a different point. Let's find out what the value of y is when x is 0. So when x is 0, 2 times 0 is 0, and this goes away. That makes y equal to 2, doesn't it? 3 times 2 is 6. So that's a point right up here. Okay, looks like we're going up 2 and over 3, up 2 over 3, up 2 over 3. Let's draw the line. We're going to draw the line. Okay, this line is the graph of my original equation. Okay, now we want to know, where is this point? We're going to go 4 to the left. Count it with me. 1, 2, 3, 4, and then go up 1, 2. Okay, that's this point, and we want to draw a line that's parallel with my original line. So here's another line with the same slope. Look, the same slope. We're going down 2 and over 3, down 2 and over 3. See what I'm doing? Down 2 and over 3. It's the same slope as my original. Okay? Since it has the same slope, then it must look like this. This is going to be the graph of my second line. Okay, so the graph of the original line looks like this right here. That's the original. The parallel's down here, and the equation looks like this with the same slope. Okay? Now we have to know what is the value over here, and that means we need to use the point -4, 3 again. So in place of x, plug in the -4. In place of y, plug in what? This number right here. So we're going to get -8, and plus 9 is 1. So when this value is a 1 right here, we know it goes through that point and it's parallel to the original line. Okay? So this is the line that's parallel to this line, but this line goes through the point -4, 3. Now we're going to change the word from parallel to what? Perpendicular. I want the line that's at right angles to the original line. What am I talking about? Right angles, 90 degrees. Well, what does the slope have to be to get a line looking like this? What's the slope going to have to be? Let's see. We're going up 1, 2, 3, and over 2, and we're going to the right. So now my slope is we're going up 3 and over 2 to the right. Okay, this is the slope of the perpendicular line, perpendicular to my original line. Okay, what's the equation going to look like? Well, 3 is going to have to go in front of the x. Since this is a plus slope, we're going to have a minus right here, and the 2 is going to go in front of the y. Okay, so this is the equation. It's going to be part of the equation of the perpendicular line. Okay, now that's going to equal something, and how do we figure out what it equals? Well, we plug in the point -4, 5. In place of x, we put -4. In place of y, we put the 5. So now I'm getting -12, excuse me. Here's your -10 over here. And when you add them, you're going to get -22. So when this is -22, we know it goes to the point -4, 5. Okay? So this is the line that's perpendicular to the original line going through the point -4, 5. Now let's review a little bit. This was my original line. Okay, that's the original line. To get a perpendicular, the 3 must go in front of the x. If this is plus, it's got to change signs, and the 2 must go in front of the y. And then when you plug -4, 5 in, you get your negative 22. All right, now this is the slope-intercept form of the equation. This is the point-slope form. This is the standard form. This is a line that's a horizontal line. And this is a vertical line.